similar solids have the same shape, but not the same size. Two solids are similar if the ratio of their linear measurements are equal. So we're going to talk about what linear measurements are. Linear measures are your units, and they will be talked about in terms of length, width, height, slant height, perimeter, radius, diameter, or circumference. And you'll find out that these answers will be in feet, centimeters, kilometers. So it's units. We're going to determine if the two pyramids below are similar. And what we're going to do is we're going to compare the height to the height, the length to the length, and the width to the width. Height is 12 in the big figure and 3 in the small. Length is 20 in the big picture and 5 in the small. And width is 8 to 2. Up top, you'll notice this says always reduce. So let's reduce each one of these and let's find out what the scale factor is. Okay, so we take the height to the height, length to the length, width to the width, and we set up our scale factor, and everything reduces to 4 over 1, 4 over 1, and 4 over 1. So the question is, are these figures similar? Yes, they are. What's the scale factor? It is 4 to 1. What does that mean? That means the larger figure is 4 times the smaller figure. The question is, are these solids similar? So what we're given the sides, and we're going to go ahead and write in the height to the height, the length to the length, and the width to the width, and we're going to find the scale factor and determine if they are similar. So here we have it. Now the next thing we need to do is we just need to simplify or reduce. That's always the first thing that we do. So we're going to reduce 8 over 12. We're going to reduce 6 over 10 and 6 over 10. We have two sides that are the same. Let's see what we get. So I've simplified my ratios here at the bottom, and I get 2/3, 3/5, and 3/5. So if the ratios are all the same, it is similar solids. If they're different, we are going to have to do what? Say no. Are the cylinders similar? Well, you've tried it, and let's see if we get the same thing. Let's compare radius to radius. This one is a little tricky. Look at this. They're giving you the diameter. However, what is the radius? The radius is 12. What's the radius in my other figure? It is 10. What's the height in the first figure? It is 30, and the height in the second one that's lying down is 25. All right, let's simplify and see if we can get the same scale factor. All right, after reducing, because that's what we do first, the size that we are given, we find out that the radius to the radius is 6 to 5, and the height to the height is 6 to 5. Question, are these solids similar? And the answer is yes. What is the scale factor? And the scale factor is 6 to 5. So we just did a lot of practicing on finding the scale factor. What we're going to do now is we're going to build on finding the scale factor, and we're going to be able to find the volume and the surface area using ratios. So here, the surface area is going to be, looks a little different right here. So let's go ahead and make this change right here. This should read, the surface area is a squared to b squared. Sometimes when I pull in my PowerPoints, they don't come out like they were when I designed them. So surface area is going to be a squared to b squared. And volume is going to be a to the third power to b to the third power, just like in your booklets. So if you are given surface area volume, we definitely want to go to finding the scale factor first. And the best way to do it is to practice. Let's go. So what we're going to do is we're going to identify the scale factor for each pair of similar solids. So they're telling us that they are similar, so that's nothing we have to figure out. So we can just take one side and compare it to its corresponding side. Watch this. Okay, so I'm comparing the base of the triangle to the base of the other triangle. That's 14 to 7. We simplify that and we get 2 to 1. What does that mean? That means that our scale factor is 2 to 1. The bigger figure is twice the size of the smaller figure. So let's go ahead and write that in. There we go, 2 to 1. Well, according to the notes we just read, once we find the scale factor first, which is what our arrow indicates, we can find the surface area by squaring A and squaring B. So I'm going to go 2 squared to 1 squared. So that's going to be simplified to what? You got it, 4 to 1. Well, let's see what the volume is going to be. So here are the ratios. 2 to 1 for scale factor. When we're looking for area, and area is always in square units, we have 4 to 1. Volume is always in cubic units, and so we have 8 to 1. Here again, we're going to identify the scale factor, and then we're going to be able to find the ratio for the surface area and the volume. All right, so we took one side to one side. We have 4 to 6. We simplify that, and we get 2 to 3. So our scale factor is going to be 2 to 3. Surface area is going to be 2 squared to 3 squared, which is 4 to 9. Volume is going to be to the third power, so 2 to the third power is 8, and 3 to the third power is 27. All right, so this question says identify the scale factor. However, I'm noticing that they did not give me a side to a side. They actually gave me the surface area. First thing I want to do, write it as a ratio and reduce. All right, the ratio for the ratio for the surface area is 25 to 4. It does not reduce. We're going to go ahead and write it in on this line, 25 to 4. So no matter what we're given, we write it in and we always go to the scale factor. Well, we know surface area is to the second power. And so to get to the scale factor, I'm going to do the square root of 25 over the square root of 4. And I get 5 to 2. Well, then how do I get to volume? Well, volume is cubic units. And so if I'm going to do volume, I'm going to do 5 to the third power to 2 to the third power. So what would that be? You got it, 125 to 8. All right, identify the scale factor. Let's see what we're given. Oh, we're given volume. So let's go ahead and write it as a ratio. We're going to do the first thing, which is to reduce. All right, this is volume. So I write it to the third power and 162 to 384. When I put that in my calculator and simplify it, it comes to 27 to 64. So I'm going to write that for the ratio for the volume. We said earlier, no matter what you're given, you write it in and always try to go back to the scale factor. Well, I know volume is to the third power, and so I need to get back to the first power. There is a cubed root key in your calculator under math. It'll look like this. You'll pull up that key, you'll go ahead and put in 27, and you will get out 3. You would do the same thing with 64, and when you do the cube root of 64, you'll get 4. Why? Because 4 times 4 times 4 is equal to 64. So what is my ratio? My ratio is, let me go ahead and erase that and make it neater. So my ratio is 3 to 4. So if my scale factor ratio is 3 to 4, what is my surface area? It's 3 squared to 4 squared, which is 16. So here are my ratios. You try this one, and then I'll fill in the answers, and let's see if we get the same thing. Alrighty, let's see what we did here. What we did was we found the ratio, and then once we found the ratio, 64 to 25, that's area. We put it under the location for area ratio. And then once we found the area ratio, to go back to the scale factor, To go from a second power to a first power, we take the square root. So that's 8 to 5. Volume is cubed, so I take 8 cubed over 5 cubed and get 512 to 125. Word problem, you gotta love it. But what you want to do is you want to circle keywords. Okay, so we're given the height ratio, which is our linear measurement. So that's your a to the first power, b to the first power, and so that's 7 to 3. And it says find the ratio of the volume. And so volume we know is a to the third power, b to the third power. So what do? We do 7 to the third power and 3 to the third power. And voila, here we go. Just read through the problem, circled the information that's given, what we needed to find. We went from first power to third power, and there's the answer. The ratio is 343 to 27. Reading through this problem, pyramid A to pyramid B, they are definitely similar. That should tell you that it's going to be a ratio. We are given the volume, and we need to find the surface area. So let's go ahead and write down what we're given. We're given the volume, so that's going to be to the third power. And so the volume is 648 to 1029. What we want to do is we want to go back to the first power. But first we have to see if this simplifies. So let's check it out. So this simplifies to 216 over 343. That's why it's very important that whatever you're given, you try to simplify first. All right, so we need to go from the third power to the first power. We need to go from third power to the first power. To do that, we're going to take the cube root of 216, and we're going to take the cube root of 343. Let's see what we get. All right, so we get 6 to 7, but that doesn't answer the question. The question is asking for the ratio of the surface area. So that's going to be a squared to b squared. So what I'm going to do is I'm going to square 6, and I get 36. And I'm going to square 7, and I get 49. So what's the ratio of the surface area of pyramid A to pyramid B? It is none other than 36 to 49. Thank you for listening.